In January of 1957, Montreal, Canada was suffering the coldest winter on record. Temperatures reached minus 36 degrees Fahrenheit, and heavy snow prevented movement throughout the city. Industrial plants and large manufacturers struggled to continue their operations despite the cold. Meanwhile, Velan Engineering was in its first decade of designing and manufacturing steam traps. Founder and CEO Mr. A.K. Velan was attempting to change the world of steam traps by designing innovative products that focused on solving the problems common to industry at the time. The extreme conditions in the winter of 1957 highlighted a major problem inherent in the technology of the time. Steam traps, which many considered to be minor, inexpensive components of process and heating systems, were capable of causing serious damage to large, expensive heating coils, heat exchangers, and process equipment. Mr. Velan recognized that mechanical steam traps, in order to avoid damaging the equipment they served, must only fail in the open position, guaranteeing drainage and preventing freezing inside of the coil. Since 1932, conventional float and thermostatic steam traps have been widely used on process and heating equipment throughout North America. Consisting of a float mechanism to control the discharge of condensate and a thermostatic bellows to control the discharge of air and non-condensable gases, the conventional F&T trap brought several disadvantages. First of all, if the float ruptured, the trap was rendered inoperable and the equipment could become waterlogged or freeze. Float rupture is typically due to water hammer or corrosion. Secondly, if the thermostatic bellows ruptured, the steam trap would not vent air from the system during startup and the equipment would be unable to drain. The bellows typically fail due to water hammer, superheat, or simply metal fatigue. Also, the location of the float mechanism at an elevation above the bottom of the trap meant that there was always water present in the trap body. This could lead to freezing during shutdown periods, as well as excess corrosion during the summer months when heating equipment was normally turned off. While the float traps of Mr. Velan's day were widely used, they presented constant problems for operations and maintenance in industrial plants throughout the world. Since 1950, Velan had been manufacturing bimetallic steam traps for drip leg and steam tracing applications. These traps already possessed the characteristic of failing only in the open position. However, the challenge was to modify this design for use on large process and forced heat applications. In hindsight, the solution was simple. Velan thermostatic steam traps were based upon the principle of a free-floating and rotating ball valve placed on the downstream side of a stellite valve seat and being actuated by a multi-segment bimetallic element. The result was a steam trap that combined high energy efficiency with long service life and a failure mode always in the open position. Mr. Velan recognized that the addition of a float to the original bimetallic design would make them suitable for operation in conditions where condensate load and steam pressure fluctuate rapidly. This combination float and bimetallic trap represents a marriage of the best of both designs. The bimetallic element controls the closing of the steam trap thermostatically, ensuring that the trap remain open when subjected to temperatures below that of steam. However, the float opens the steam trap mechanically, ensuring that all condensate is discharged immediately when it reaches the trap. At startup, the bimetal element is relaxed and the valve is open wide, allowing for rapid discharge of cold condensate and non-condensable gases. As the temperature of the condensate increases, the bimetal element pulls the valve closed. In the presence of live steam, the valve remains closed tightly. As the temperature of the condensate cools slightly, the bimetal elements relax and the valve is opened. When large amounts of condensate reach the trap, the float opens the valve fully, ensuring complete drainage of the equipment. In the event of a sudden drop in upstream pressure, the valve and seat arrangement act as a check valve, preventing reverse flow in the system. The Velan float and bimetallic steam trap remains unique in the market today. By requiring heat from steam to close the trap, the Velan MFT cannot fail in the closed position, protecting process coils and heat exchangers from damage due to freezing and waterlogging. The design of the ball valve on the outlet side of the orifice provides complete resistance from damage due to water hammer and overpressure. The inherent durability of bimetallic air venting makes the Velan MFT superior to conventional float thermostatic steam traps that use liquid-filled bellows. Protect your investment in your process equipment with the use of Velan float bimetallic steam traps. Velan steam traps are manufactured in compliance with all major international quality standards using the most durable materials available today. A dedication to continuous product improvement and on-time delivery make Velan a worldwide leader in the design and manufacture of steam traps. For over 60 years, Velan has been the steam trap of choice when durability, rugged construction, energy efficiency, and critical drainage requirements are needed.